Hello, I'm Shiny, and I'm going to demonstrate today our first lab report one for data collection and quality. So lab one consisted three tasks. For task one, it's web scraping lab report basically. For task one, we have to choose topic like machine learning, artificial intelligence, deep learning, regression, etc. And we have to search for reliable sources. And we have to choose two website and scrap the deadline and textual data information from these two website and store in a text file. This is our task one, basically scrapping textual data, headline, and content. So let's start with that. Firstly, we have to import some libraries like request, beautiful soup, and OS. Request is basically fetches web pages, and beautiful soup is basically passes HTML, so we can extract tags like H1, like heading, and contain in it like p, and os is used basically for output or folder exit so that we can save the data without any fail. So this is the thing for output directory. We have used OS, and we have fixed the output file path as well. And for articles, we have used two URLs, like two web page, as it is mentioned in the task one. One is technology review, and next one is science daily. So we will scrap data from these two website. So, for open file for writing, like we have used um, if dot write basically, and for this, I would like to share a thing like for if dot write, if we use like um, sorry, this out file name, that is os.path.join, if we all put it one block, so instead of, so we can ignore our IO closed, IO errors, because while I was doing this, I faced a lot of error related to IO. So for this, and we use that if dot write basically for task one, web scraping. It's basically to write title the text file. Okay, so for article one and article two, it is basically for URL one and two. And we have used that soup equal to beautiful soup to convert HTML to a researchable beautiful soup object. And for heading element, so most article title in headlines, basically we guard if heading element to avoid crashes. And after that, for body element, um, and we have chosen soup.find. And for again, if dot write, it is basically using to extract the heading and content out of the website. And for printing, we have used this one. And for article 2, we did the same thing. And to save this in text file, so we used print, just scrapping complete file saved this one. So it can automatically save the text file. For task one, I can show you the text file. This is the text file, and it has scrapped the heading as well and corresponding the content data. Okay, let's dive into the next task. So task two is about choosing an e-commerce website and then scrapping name and cost of the product, and storing the detail again. At the end of the task, we have to store the detail in a CSV file. So for this, we have to import libraries just before, like beautiful soap, request, pandas, and OS. And for this, what exactly we have to do? Like for uh, this is the same thing like before. And for URL, is we have to say the target URL as Elgigaten. I have chosen Elgigaten as the main URL, and for user agent, I have used Mozilla. Okay, so for headers, sometimes site block non-browser user agent. So using a common user agent makes the request look like a browser. So that's why we have to use that UA, that is user agent. Okay. And for e-commerce site basically often use product card classes. So if if we would like to found a big parent like you want, then you can also use soup.select. And if the status code is 200, it is absolutely fine. And after that, to save the CSV file, so it is basically, um, sorry if I miss anything. Okay. For sparse page, we have used soup, beautiful soup that response.content for sparse, and for product list, as we have to find the name. So it is is container equal to soup dot find we have used, and to collect the product data. This is a product. This is for product name, name tag, and to get the price tag. So this is the way. And for print, both product name and price, we have used this section. And to save directly as CSV file, so we use that df equal to pd to save the data. I can show you how it is saved. This is the task to product and price data. This is CSV file. This is the product and price column. You can check from here, and it is ready to analysis. Okay. And let's dive into the task 3. It is basically to scrap weather data with error handling from two weather website. And at the end of the end of the task, we have to save the data in the text file. So as before, we have to, sorry, we have to import request and beautiful soap, import date time as well to have the weather data. And for this, we need two things, like as we have selected time and date, this website and weather.com website. So we to scrap the data from these two website, we have used this def for both the cases. And this is the thing for response, and dot trace for status, and so for beautiful soap to extract the data. And the thing is, mm, and for sparse, basically each weather site has different HTML. Isolating the sparse into function, it makes so much clear. And for temperature, we have used soup.find in both the cases. And for condition, weather condition, we use soup.find again. And to extract the data, and then we run both the scrap, like scrap time and date and scrapweather.com, and we have saved the text file. For this, we use if.write to save the weather data and to extract the weather data. And for print, we have used this print data and save as txt file, text file. I can show you the text file as well. This is our task 3 weather. So this is it, the weather of Stockholm. Time, the temperature, it was 11 degree, and condition was clear. I mean weather condition is clear. So yes, this is it. And with this, I'm going to end my presentation here. Thank you so much.